Well, with the current state of computer technology, I'm in principle able to model objects like, let's say, this apple to such a level of detail and to such an extent that in no way differs from the original. Except for taste. The objects I'm interested in are much bigger than that. Seriously, I'm talking about something gigantic. Well, I've always been interested in stars since I was a kid. I remember reading in a book that elements like carbon, nitrogen and oxygen that make life possible on Earth are all made in stars. And I found the idea fascinating and mind-blowing, and I wanted to know more, and I still do today. I also find very intriguing that we are discovering that most stars actually harbor planets. And if we want to understand these distant worlds, we need to understand the stars around which they orbit. Well, that depends of course on the model one assumes. Traditional models usually treat the stars and the Sun as spherical objects to first approximation, and therefore predict stellar surfaces that are perfectly homogeneous and flat. Modern 3D models instead account for inhomogeneities in stars and therefore predict stellar surfaces that have a texture. The model surface of the Sun, for instance, shows a so-called granulation pattern, with bright extended patches of warm gas about 2,000 km wide, which we call the granules, surrounded by a dark network of cool gas. This pattern is not static, but constantly changes with time, with a typical granule lasting for about 10 to 20 minutes. Some compare the visible surface of the Sun to the surface of a boiling liquid like water. This analogy is, however, a gross simplification of the real picture. I'd say the surface of the Sun looks more like it's covered in large bright hills consisting of hot gas that flows upwards at the center, cools down and falls back along the hillsides. This texture is not static at all, but very dynamic, with new hills constantly emerging at the surface and old ones coalescing together, splitting or vanishing. From models we can learn about the structure of stellar interiors and about the physical conditions, temperature and pressure of the central regions of stars, as well as physical processes that occur in stars like nuclear fusion reactions, which we cannot otherwise observe directly with the naked eye and not even with telescopes. Well, my model looks surprisingly good compared to that huge thing that is nearly 1.5 million kilometers in diameter. The main prerequisite to model a star is a very good understanding of physics in general. One of the most fascinating things about nature is that the same physical laws that apply to Earth also apply to matter elsewhere in the universe. Stellar matter, however, is exposed to temperatures, pressures and other physical conditions in general that are too extreme to be reproduced in even the most advanced laboratories on Earth. So we have to trust that our physical theories are valid and that they can be applied to these extreme environments when we build models of stars. Basically, right now we can only compare directly the predictions from theoretical models of stellar surfaces with specially resolved observations of our own Sun. Unfortunately, we do not have the technology yet to carry out similar observations for the stars in general. However, perhaps in 10-20 years' time, with the next generation of extremely large telescopes, we will be able to routinely observe in great detail the surface of other stars. Only then we will be able to truly observe the faces of stars and see what they really look like.